Hello and welcome to this semester review over Matter and Change 1. My name is Ms. Horn and I will be your tutor for today. Please have out your hot pink semester review and a periodic table to guide you. Today I'll be starting on number 34, which says to contrast the three states of matter in terms of shape and volume, if they're definite or indefinite. Okay? So right now, my simulation shows water at negative 10 degrees Celsius, which is as its solid state. So in its solid state, as you can see, the particles are very tightly compacted. In addition to that, the volume and the shape are definite. What I mean by that is it has its own definite shape. It cannot be changed by some other variable. It has its own definite shape. It is a solid. And the volume can be measured, so it is definite as well. I'm going to go ahead and heat this up and make it a liquid. So now that it's a liquid, you can see that it is taking the shape of its container, which means that the shape is indefinite. However, I can still measure the volume of this, so the volume is definite. I could say there are 30 milliliters of water in this beaker. Okay, that's a definite volume. Now I'm going to heat it up even more, and you can see that it's boiling and evaporating, turning into steam. Well, the particles are now loosely compacted, and the shape and volume are now indefinite. Okay. A gas is going to take the shape of its container, and the volume is indefinite as well. Okay, moving on. Number 39 says consider the following equation. CH4 plus 2O2 yields CO2 plus 2H2O. If the mass of the reactant is 80 grams and the mass of carbon dioxide is 44 grams, what is the mass of the water? What law does this illustrate? Let's look closer at this equation. I need to know what products and reactants are. The reactants are on the left side, and the products are on the right side. And they're separated by an arrow in the center. Okay? So the CH4, which is just a hydrocarbon, and the oxygen are my reactants, and the products are the carbon dioxide and the water. Well, it's telling me the mass of the reactant is 80 grams, and the mass of the carbon dioxide is 44 grams, and wants to know what is the mass of water. So if I set this up like a simple algebra problem, where the equal sign is replacing the arrow, I can solve this very easily. Okay? I don't know what the mass of water is, so it becomes x, or the unknown. Okay? This is going to follow a law that we call the conservation of mass. The law of conservation of mass says that mass cannot be created nor destroyed. So the mass of my reactant must equal the mass of the products. You can think of this as a balance. And at all times, an equation must be balanced. So in order to solve for x, I'm going to subtract 44 grams from both sides. And I get x is equal to 36 grams of water. Okay. Moving on to the next one, 40. It says, what is the difference between a chemical property and a physical property? Well, if you look on the answer sheet, it says a chemical property is determined by the reactivity of a substance, and a physical property is determined without a chemical reaction taking place. Okay. Well, in addition to knowing what a chemical property and a physical property is, you need to know when a chemical change or a physical change occurs. So a chemical change, okay, it's occurring when a new substance is produced, and these are generally not reversible. That's a dead giveaway. If you cannot reverse the symptoms, then it's going to be a chemical change. So for example, down here, rotting meat, it'll never be good again. So this is not reversible. That would be a chemical change. And there are some different things that you will observe that will help you to tell if something is a chemical or physical change. So some things that will show a chemical change are precipitate formed, if a gas is formed, lights produced, if there is an energy or temperature change, or a permanent color change. Those are all indicators of a chemical change. On the other hand, for physical change, no new substance will be produced. And these are usually phase changes. So, for example, when ice melts to water, well, ice is just solid water. So this is just a phase change. And these are always reversible. So if you can change something, like for example, when the ice melts to water, all I have to do is stick it back in the freezer and it'll turn back into ice. That's a physical change. Number 42. What's an intensive property and an extensive property? Okay, well, an intensive property is something that does not change according to amount. So does not change based on amount. And we talked about this a little bit earlier in my last segment, that an example of this would be density. Density is a constant for every type of material. So it doesn't matter how much of a substance I have, the density will always be the same. Extensive is just the opposite. It does change based on amount. So we say this is dependent on amount. And an example of this would be mass. Okay, so the more chocolate I have, the more mass it's going to weigh, or the more amount in grams it will weigh. That is very dependent on amount. Okay, so if I have this piece of chocolate, its mass is going to be higher than this little piece of chocolate. Okay, so it is dependent on the amount. Number 43. How can exothermic and endothermic reactions be identified? Okay, so for an endothermic reaction, it's when something absorbs energy. So, for example, if you're going from a liquid to a gas, do you agree that you have to add energy or you have to add heat to this in order for this to occur? So we can say that going from a liquid to a gas, known as boiling, is an endothermic process. Exothermic, on the other hand, is just the opposite. This is when energy is released. And an example of this would be going from a liquid to a solid. Energy has to be released in order to freeze something. The next question. Which type of thermal energy transfer is occurring in each of the following? Okay, so our options here are going to be conduction, convection, and radiation. So number 54 says, a flask on a hot plate becomes warm after the hot plate is turned on. 55 says hot steam from the shower warms the air in the bathroom. And 56 says sunlight travels through space to the earth. Well, for me, the easiest one to identify is always radiation because it has something to do with sunlight. So I know when I see the word sunlight that this is immediately radiation. Now, conduction and convection, they're very different. It's just tough to distinguish them because the names are so close. Now, conduction means when something is physically touching. So, in 54, the flask is on the hot plate. So it is touching, which makes this conduction. And for 55, hot steam from the shower warms the air in the bathroom. It's just a transfer of energy. So this is convection. So it's physically touching, you know it's conduction. And if it has something to do with sunlight, it's radiation. Okay, this concludes my segment on matter and change 1. If you need more information on this topic, you can visit my website at academicchemistry.pbworks.com and go to the navigation bar on the right side and click on matter and change 1. Good luck studying!